This video is just going to give us a quick comparison between the C8, the C9.25 and the C11 SCT schmidt-cassegrains from Celestron. So to start off with each of the three scopes, I'm going to test them using the Celestron 0.63 reducer with 105 mils of backspacing to the SC705C planetary camera. I've mounted SV Bonnie power boxes on all of the scopes. The C8's got the Pro version, the other two are the standard. The C8's got the Celestron focuser on it. We move across here, the C9.25 and the C11 have both got the SV Bonnie boxes as well, but they've also got ZWO focusers mounted with 3D printed parts. So I've set the mount up in the daytime. I've got it pointed off in the distance to a power pole up on top of the hill, just to give us a rough field of view for each of the three scopes using the reducer. So that was the C8. Now here's the C9.25. Same target to a power pole off in the distance. A very similar field of view. And then we move to the C11. And obviously the field of view is a lot smaller. It's more zoomed in. Now we give a side-by-side comparative. The C8, the C9 aren't that much different. The C11's clearly got a longer focal length. Now I'll do a quick daytime test of the moon with all three scopes. Here's the results in sharp cap. Tried to keep the exposures and everything the same. But again, across all three scopes we've got good contrast. This is the C8. The C9.25, the field of view, again, is very similar. There's only basically 60 mils of difference. When you move into the C11 is when you notice the big difference in the field of view. It's sitting at 1680 millimeter focal length. So when it got dark, I decided to leave it in Alt-Az mode and test all three scopes on the bug nebula. Taking 120 5-second subs, stacking them, and then we'll compare them. Now the AZ EQ6 Pro from Skywatcher handles the C11 in Alt-Az mode, but in Equatorial mode it's sort of pushing the friendship a little bit. Here's the stacked result for the C8. Notice the field rotation because it's in Alt-Azimuth mode, unguided. Here's the C9.25. We're starting to get a bit of vignetting. And here's the C11. Now we're going to change the imaging rig over. So we've still got the Celestron 0.63 reducer with 105 mils of backspacing, which includes the SV Bonnie off-axis guider, the filter draw, and the APS-C size SC571 camera. Now the mount's been changed over to Equatorial mode because we're guiding, a lot more accurate, and I'm taking 5-minute exposures, 300 seconds. You'll notice all three scopes have got thermal blanket wrapped around them too. It's to stop the fluctuation in the temperature, to stabilise the inside of the tube so you don't get the boiling effect of the atmosphere. So here's a single 5-minute exposure from a C8, a single 5-minute exposure from a C9.25, and a single 5-minute exposure from the C11. So let's compare the images side by side. We'll start with the bug nebula. Now this is the C8, the C9.25, the C11. They've all got 120 times 5-second exposures stacked, so 10 minutes of total exposure time. There's no calibration frames, and this is in Alt-Azimuth mode. So here's the C8. Notice the dark edges, that's the field rotation. The C9, fairly similar field of view. So Nina was plate solving the C8 at 1280, which was to be expected. The C9.25 should be at 1480, but it's actually plate solving it at 1340, so the spacing might be a little bit out. Then the C11, now this should be plate solving at 17, let me double check it. Yeah, 1764, and it's actually plate solving at 1680, so it's pretty close, but it's still, the spacing might be a little bit out. Now if we zoom in closer and have a look at the detail of the nebula, and we'll carry that across all three, you can see the field of view's much more zoomed in on the C11. Now from the C8 there is detail there, the C9 gets a lot crisper and a lot sharper, and then the C11 you start to see a lot more detail in the dark structure. Okay, now we move on to the equatorial mode. So this is the NGC 6334, the Cat's Paw Nebula. Now these were 5-minute exposures, so there's 12 in each, so there's an hour stacked, no calibration frames, because I wanted to keep it sort of relatively even. So we'll start with the C8. Here's the full frame image. Now you can see the vignetting from the focal reducer, and it doesn't really get much better. The C9.25 is the same, and then the C11, while the field of view is smaller, it's more zoomed in, there is still some significant vignetting on it. Now this could be to do with the fact that it's an APS-C size sensor. Now if we zoom in closer and have a look at some of the detail. So this is the C8. We're starting to pull the dark structure out of the nebula. I'll carry that across to the 925. You see it's a lot sharper, there's a lot more detail, it doesn't look quite as blurry. Fairly similar field of view. And then we carry it across to the C11. Now we just got to find the bit we're looking for, which is there. Yeah, so we got a smaller field of view again, it is more zoomed in. But you do start to see a lot more detail. So for the same amount of time between all three, I honestly think between the three of them, the C9.25 is really the sweet spot, because you get that good detail without the extra weight of the bigger tube. So while it is a fairly crude comparison, I hope this gives you some idea of the differences you can expect going from a C8 all the way through to the C11. As I said, I think the C9.25 is the better scope out of the three, just because of the weight. So the C11 is fairly restricted. You need a lot larger mount to handle it and that sort of thing. So anyway, thanks for watching. Like and subscribe, that'd be much appreciated. And yeah, I'll see you on the next one.